Today we're going to be learning how to factor a trinomial, and our objective is that we will be able to factor a quadratic expression. So, when we're factoring a trinomial, which is a polynomial with three terms. So, step one, just like the last couple classes, factor out the GCF if there is one. Next, we're going to multiply a and c. So our polynomials are always going to be written as ax squared plus bx plus c. So we're going to multiply the number in front of the x squared and the number at the end that's a constant that doesn't have a variable with it. Next, we're going to find a pair of factors of that answer from step 2 that add up to give us the number that's in front of the x term. Next, we're going to rewrite b as two terms using the factors that we found in step 3. That will give us a polynomial with 4 terms, which we learned how to factor last class by grouping. Now I know these steps sound a little bit weird, they'll make more sense when we look at it in a problem that actually has some numbers. So, in our first example, the first thing we want to look for is a GCF. All of these are divisible by 7 and we can take x cubed out. Once we've done that, we're left with x squared minus 5x plus 4. So you don't see it, but there's a 1 there. That's A. Negative 5 is B. And positive 4 is C. So A times C would be 1 times 4, which is 4. So things that multiply to 4. 1 times 4, 4 times 1, 2 times 2. Now, we want to add to negative 5, but multiply to positive 4. That tells us both terms need to be negative, because that's the only way that that will work. Which pair adds up to negative 5? Either negative 1 and 4 or negative 4 and 1. Either way, that'll work. And the order we rewrite them here doesn't matter. So we're going to take our negative 5x and we're going to split it up into 2 terms. We're going to have negative 1x and negative 4x. And I'm going to bring down my x squared term and bring down my c term. I'll come back to the GCF at the end. So now we're factoring by grouping. Remember, if there's a minus in the middle, we're going to change it to plus and negative. Group the first 2, group the second 2. These 2 have an x in common. Take that out. We're left with x minus 1. We have negative 4x plus 4. I know they have a 4 in common, but since we know we want the parentheses to match, to get a minus 1 at the end, we'd have to divide by negative 4. X minus 1. So my factors are x minus 1 and x minus 4. Then for my previous terms, I'm going to bring down my 7x cubed, parentheses around the whole thing, 7x cubed, parentheses around the whole thing, 7x cubed as part of my final answer. So let's look at another example. 4x squared plus 8x plus 3. Does this have a GCF? You're right, it doesn't. So we're going to start off by multiplying a and c. 4 times 3 gives us 12. Since this multiplied to be a positive and 8 is positive, we know that all our factors will be positive. So 1 times 12, 2 times 6, 3 times 4. Which of those pairs adds up to 8? The 2 and the 6 does. So we're going to split 8x up into 2x and 6x. Bring down our a squared term, ax squared. Bring down our c term and group. These two have a 2x in common, and I'm left with 2x plus 1. These two terms have a 3 in common. Divide both by 3, I get 2x plus 1. So my factors are 2x plus 1 and 2x plus 3. All right, some definitions. Standard form of a quadratic. We kind of talked about this already. It's ax squared plus bx plus c, and it has to equal 0. We always want the x squared first, the bx second, and the c in the end, and then our equation, which we're going to get into, equations instead of just expressions, has to be equal to 0. The reason we want it equal to 0 is so we can use the zero product property, which says if a times b equals 0, then either a equals 0 or b equals 0. Or both of them could equal 0. Because 0 times 27 is 0, 15 times 0 is 0, 0 times 0 is 0. So let's see how we put this to use. Here we have two parentheses being multiplied equal to 0. Think of this as the a from that definition, and this is the b from that definition. So either x plus 13 equals 0, or x plus 5 equals 0. Well, let's solve these and see what x could be. Subtract the 13. X could equal negative 13, or if we subtract the 5, x could equal negative 5. So you could write them separately like that. You could write them as x equals negative 13 and negative 5. Or if you wanted, you could use curly brackets and put negative 13, comma, negative 5. This. Make sure if you're going to write it this way, though, that you use curly brackets and not parentheses. Curly brackets mean a list. Parentheses mean a coordinate point. And you don't have to write it all 3 ways every time. Just pick whichever one you like best. So this example, we don't have the parentheses yet, but we've learned how to factor, so we can get the parentheses. Since it equals 0, we can start off with our factoring steps. Do these 3 terms have a GCF? They do not. So multiply a and c. 3 times 2 is 6. Since we're multiplying to a positive and adding to a negative, we know both terms will be negative. So 1 times 6 or 2 times 3. We know we want negatives for all the terms. Otherwise, it won't multiply to be positive. Which pair adds up to negative 5? Negative 2 and negative 3 does. So we're going to take our negative 5x and split it up into negative 2x and negative 3x. Bring down the 3x squared plus 2, also bring down the 0. Now we're ready to group. Group the first two, change this to plus and negative, and group the second two. What do the first two have in common? They both have an x. And then if we take that out, we'd be left with 3x minus 2. Here we have a negative in front of the 3x and a positive 2, which means we're going to want to take out negative 1, which will leave us with 3x minus 2. Bring down the equals 0. So that means our factors are 3x minus 2 and x minus 1 equals 0. Now we can split them up like we did in this first solve by factoring example. Either 3x minus 2 equals 0 or x minus 1 equals 0. Or they both do. So to solve this, add 2, 3x equals 2. So when we divide, we get that x equals 2/3. This one would give us x equals 1. So those are our two answers. Let's look at a couple more examples. All right, these examples, neither of them equals 0 to start, so we're going to need to make them equal 0. I'm going to move these two things just because there's less stuff on that side. Minus 2d cubed. I'm going to put that under the other d cubed term. Minus 2d. I'm going to put that under the other d term. So 3d cubed minus 2d cubed would just be 1d cubed minus 3d squared. Negative 8d and negative 2d would be negative 10d, and all of this cancels, so it equals 0. Don't let the equals 0 run away. If you start with equals, you got to have equals in every step. Next, we check to see if there's a GCF for the entire polynomial. There is. All three terms have a d, so I'm going to factor that out. Be left with d squared minus 3d minus 10 equals 0. I'm going to ignore the GCF right now. There's a 1 in front of the d squared. 1 times negative 10 is negative 10. Now, I'm not sure if you remember from earlier math classes, but if you're going to multiply to get a negative, one term has to be negative and one term has to be positive. So it could be 1 times negative 10. It could be negative 1 times positive 10. It could be positive 2 and negative 5. It could be negative 2 and positive 5. Those are all our options. So if we have a negative number when we multiply a and c, that's going to give us twice as many possibilities. Which one of those three adds up to, which one of those four adds up to negative 3? It would be this one here, positive 2 and negative 5. So let's rewrite our middle term, plus 2d minus 5d. Bring down our d squared and our minus 10. Something I forgot to mention, it doesn't matter if you did minus 5d plus 2d. The order of these two don't matter. Just make sure the signs match up with what we wanted. Now I'm going to group. First two, change this to plus and negative. Group the second two. Oops, don't forget to bring down your equal 0. I almost forgot. These two have a d in common, which would leave us with d plus 2. These are both negative, and we don't want a negative in our second parenthesis, so I'm going to take out a negative, and they're both divisible by 5. D plus 2 equals 0, which means my factors are d plus 2 and d minus 5 equals 0. Now, before we go any further, we need to bring down our GCF from earlier. D, D, D. So technically here, How many things are being multiplied together? That's right, there's 3 things. So all 3 of them could be equal to 0. So d could equal 0. If we solve this, we would get d equals -2. If we solve this one, we get d equals +5. Something to notice is, at the beginning, when we had it equal to 0, we had a d cubed. We got 3 answers. Here, we started with x squared. We got 2 answers. That's not a coincidence. If you're starting with x squared, you should get 2 answers. If you're starting with a cube, you should be getting 3 answers. If you had a 5th power, you should be getting 5 answers. You'll go into that more in Algebra 2 as well. So let's look at our last example. Again, it does not equal 0, so we need to make it equal 0 first to get it ready to factor. So we have 8x squared minus 6x minus 14 equals 0. Do we have a GCF here? We do. It's a 2. That leaves us with 4x squared minus 3x minus 7. Multiply our a and our c, we get -28. So we could have 1 and -28. We could have -1 and +28. We could have 2 and -14, -2, +14. We could have 4 and -7. We could have -4 and +7. Which one of those pairs adds up to -3, our b term? That would be 4 and -7. Split up the middle term, 4x minus 7x. Bring down the -7, bring down the 4x squared, bring down the equal 0. Group, change this to plus and negative, and group. These two have 4x in common, and we're left with x plus 1. These two have a -7 in common, which would leave us with an x plus 1, which means our factors are x plus 1 and 4x minus 7. Bring down our GCF from the original problem as a 2. Here's the 2. Here's the 2. Now again, we have 3 things being multiplied, so they should all technically be set equal to 0. Now, does it make sense for 2 to equal 0? No, there's no variable with the 2, so we don't need to worry about this. Again, we started with an x squared. These two equations will give us the 2 answers that we expected when we have an x squared. Subtract the 1, we get x equals -1. Here we'll add the 7 and divide by 4 to get x equals 7/4. Don't forget to fill out your summary. That's all for today. See you in